So what we're seeing now is falls autumn.
Yeah.
That's because the trees are losing so much water. They're in their final strategy. They're in panic mode. So what they do is like, what do I do? What do I do? Right, I'm going to throw my leaves. So they throw all their leaves. It's a bit of live fast, die young mechanism, and they will try and sit it out until next spring.
Hello and welcome to Green Queens,
the perfect podcast for imperfect environmentalists.
With your hosts, myself, Abbie Dewhurst, and herself, Imogen Bhogal.
I'm sorry, I feel like I normally do that second bit and didn't, and you looked at me like, okay, I'll carry that on.
No, I was happy to take the baton. We'll swap and change and mix it up each episode.
God, we're just such kooks, changing it up all the time. Gosh. Yeah. So we have just had 3 of the most interesting and perhaps most unexpectedly interesting conversations imaginable with 3 experts. Do you want to give us a bit of context of who they were?
Well, a few weeks ago, we visited Kew Gardens, and I cannot believe it was the first time I had ever been to Kew Gardens, I think, in my life. You had been to a wedding there, and we both said we need to go back and just have a long day of picnicking outside and meandering around because it was wonderful. But our main goal was to go and look at their newest garden that they've opened, which is the Carbon Garden. It's only really opened within the last couple of months, and it's a garden that really tells so many stories around the carbon cycle, but also gives a snippet into a little bit of what we can perhaps expect our climate and our plants to look like in the future. It goes into so much detail on so many different levels, and so we kind of wanted to tap into the brains behind the people that planted the garden and designed the garden, and B, like, why the people behind the people behind the scientific research, of which I think Kew Gardens, is probably fair to say, are some of the world leaders in terms of research around plants and trees in particular, and their species and how they're all changing and adapting to the climate.
And you know, I'm going to confess something, that going into this, I was like, okay, so Kew Gardens have a carbon garden, and it's probably quite a nice thing to visit over the summer or over the autumn. And I did not expect to feel so empowered with so many juicy nuggets of knowledge. And also perhaps for the first time to really care about Year 9 science when you learn about photosynthesis and why that might be important. And to hear these experts today, and I was like, oh, it all clicks into place, and I suddenly just want to go out into the garden and look at trees and tell people loads of tree facts. And I also think that there's a lot to be enormously optimistic and feel empowered by in this particular episode, not least because I think it describes why we can look 500 years into the past and use that as inspiration to look 500 years into the future, all through the power of lovely trees.
We've had a go at answering that ourselves, but let's be honest, it's probably best to hear from the actual experts. So we asked Jo Richomme, the garden supervisor who led the team behind Kew's Carbon Garden, what exactly is it and what's it trying to achieve?
So the Carbon Garden is this brand new area that we've built and planted up here at our site in southwest London. It's designed to basically take our visitors through the whole story of carbon, and obviously we're Kew Gardens, so that we're also talking a lot about how plants and fungi play a role in the carbon cycle, but it's also a kind of we want it to be positive as well. So it's a way of telling our visitors the sort of how plants and fungi can mitigate some of the worst impacts of that changing climate.
Before we go any further, and before you do a little sly ChatGPT, let's put ourselves out of our misery. Time for the obvious, slightly silly question. What is the carbon cycle?
It's not an obvious question, actually. It's quite a difficult question in some ways. It's essentially the cycle that keeps us all here on the planet. Carbon is important to us as life, as part of life form. And the carbon cycle is essentially this sort of part of moving carbon from the atmosphere down into living tissue and then back out again. And what's happened at the moment is we've sort of disrupted that by disturbing large amounts of carbon from fossil fuels and below ground, putting too much CO2 into the atmosphere, causing us issues with greenhouse warming and warming of the atmosphere.
That was Kew's Justin Moat, a senior research leader specialising in carbon capture. A huge part of the Carbon Garden is helping people understand the carbon cycle, why it matters, how climate change is disrupting it, and most importantly, what we actually do with that knowledge, which is where Kevin Martin comes in.
Yeah, so my job is head of tree collections here at Kew. So really my job is understanding what the Kew's landscape is going to look like in 100 years' time. So a lot of my work now is basically I do lots of modelling. I do lots of climate modelling and species distribution modelling, and we use this data to start understanding the influence of climate change on our treescape.
One of the features of the Carbon Garden shows the kinds of plants we might need to grow in UK gardens by 2050, when our climate could look more like Barcelona's does today. But how dramatic is that change really? Trees are tough and ancient and resilient, aren't they, after all? What will it really look like in 100 years' time?
Very different in some areas. So from the analysis that we've done already, we know that potentially 50% of our living collection is going to be vulnerable by 2100. So that's 50% of our trees. We've got 11,000 trees. So about 5,500 are vulnerable through climate change. And that's for many reasons. Some of our natives, but also some of the areas in which we've collected from are wet Asia. We just don't have the rainfall now and the heat in order to support that vegetation. And that's what we're starting to see. This year's been a real test. And we are very brown and we're starting to lose trees quickly now, and that's because we're so hot. And what everyone has to remember is as we get warmer, and we are all getting warmer, we can't get away from that. As we get warmer, plants use more water, so you need to see an increase in precipitation. But unfortunately, when we look at our precipitation predictions up to 2100, our precipitation stays stable. So to give you an idea, the extent of change, we're currently 10 degrees on mean annual temperature. By 2100, we're going to be 14.8. So we then look at precipitation. Precipitation is around 600 at the moment, 600 mil precipitation in a given year. And that's going to stay consistent. The best we get is about 660 mil. So what we have to do is understand how much water the landscape's going to use through vegetation and evaporation. So we look at potential evapotranspiration. So currently, we are about 750 mil. So we lose approximately 750 mil of moisture from our soil through plant growth every year. By 2100, we're going to be over 875. So realistically, with soil capping and compaction, your precipitation levels would nearly be around 1,000 mil precipitation to support our current plant vegetation at Kew.
Well, it turns out the real pickle for trees is water. And we wanted to know if that's what's been behind the bizarre summer branch snapping and false autumn we've seen in the UK after such dry summers. Is this some sort of survival mechanism?
Yeah. So this is, for me, managing the trees here at Kew. You've got 11,000 of them and 2 million visitors a year is probably my biggest worry. And it's known to science, and we know it's called summer branch drop. But we don't fully understand what causes it. But I do think with these recent research that I've been doing here at Kew under xylem cavitation, I do think that's what we're seeing, is it's where these vessels are becoming air blocked. And we know from doing hydraulic scaling of the inside of a tree that if you've got an area which is really compacted on one side of the tree, those vessels then support that side of the tree. So they run it down like your plumbing system would do at home. And I think what you're seeing there when we see this sudden branch drop is where the tree, all those vessels are being disrupted. There's lots of air getting in, they're drought stress. And what happens is, as that happens, these vessels shrink, and that's when you get this big breakage. Because it goes sudden. If you ever hear one or see one, it sounds like a gunshot, and there's no warning. And you can't visually tell which tree's going to do it. I had one, it happened here on Monday, and had a big oak branch fail, and it's just collapsed. And now we've got to take the rest of the tree down because it's compromised the rest of the tree.
Yeah, so trees are pretty good at dealing with drought. And what they do with that is essentially, well, they'll drop their leaves. They will move into autumn early. If we haven't got enough water into the system, they'll kind of essentially just take things easy, wait until next year. But the issue we've got is that this is happening year upon year upon year. So we're presently moving into, in the past, sort of 20, 30 years ago, we were talking about droughts every 7 years. Now we're looking at droughts every 3 years. And this year we had actually, heat waves, 3 heat waves this year. And that really stressed the natural environment out quite badly. So the trees react to that. As I say, some trees will be fine with that. They're used to it and they'll deal with it. Other trees will have issues with it. And we need to plan for that. Certainly in our urban environments, we need to plant the right trees that will survive in those urban environments, not the ones that we'll actually lose or will have trouble with.
And the stress doesn't just show on the outside. Look inside a tree trunk and those rings aren't just age markers, they're battle scars, recording the conditions each year brought. In the carbon garden, a cross-section of an old redwood revealed the impact of a 1970s drought. The rings were tightly packed, showing the tree barely grew at all during those years. And less growth means less carbon absorbed, so these giant carbon vaults aren't quite so mighty in the tougher years.
Yeah, as we move into different environment, trees will be different species will be reacting differently. So those almost all trees will react to a drought environment by essentially reducing their growth. They'll actually put on denser wood, so the wood will actually be slightly denser at that point. So there's a kind of balance there to be gained by the tree growing slower but more dense. But yes, realistically, the more droughts we have, the more problems we've got. UK oak is probably a really classic example of that, which is now synonymous for the UK. We have this English oak, but in actual fact, it's doing quite poorly now because of the environment we're sitting in. It's too hot during summer, too wet and mild during winter, so they're not actually getting a rest period. So they're actually their growth rings are starting to shrink and shrink and shrink. So we have issues with the UK oak, and some of the teams at Kew are looking at how we might replace that with more DNA from actually different species, not different, but the same species of oak, but from different environments where it might be better to survive in the UK, especially in a hot place like Kew or London.
It's such a clear, visible reminder of the battle trees are fighting in a changing climate. But they're not in it alone. The unsung heroes of the carbon cycle, fungi. As we wandered through the carbon garden, these little powerhouses kept stealing the spotlight. But what are they actually up to?
When we're talking about sort of dealing with climate, we plant trees, we put plants in, etc. But in actual fact, especially in the terrestrial environment, most of our activities below ground, 80% of your carbon is sitting in your soils. Above ground is what we can see. Below ground is what we can't see. We can't easily sort of interact with it. And it's quite hard to sort of understand what's going on there. So part of the carbon garden is to bring that understanding. This is really unusual or intriguing relationship between trees and plants and the fungal environments below ground. The trees themselves are producing these sugars and glucose, of which they produce from photosynthesis. They're actually exchanging that with the fungal matter below ground. And the fungus is returning back to the tree water and nutrients and micronutrients that the tree needs. So this is sort of symbiotic relationship going on between the two. If you talk to their mycologists, they would actually tell you it might be the other way around. The tree's kind of just benefiting from what the fungal is doing a great job. So there's a fantastic interaction between those two, and that pushes most of your carbon into your soil. You get some carbon in your soil from leaf litter and bits of plants dropping down, but most of that interaction is actually happening at the roots of plants, between the roots of plants, fungus, and then other interactions between microorganisms, etc., eating parts and bits and bobs, etc., back and forth. So underground is really the true dark matter when we hit carbon.
This is all fascinating, but it's also starting to sound a little bit ominous. So what can we do at home to help the carbon cycle along?
I think that it's all those things that we're not very good at, so please don't be too tidy. Leaving piles of litter and not litter as in plant matter, etc., and leaf litter on the landscapes is actually much better for the soils, for those interactions between the fungals and the worms, etc. Having slightly scruffy environments, putting up with the fact that our things like grassland will die and die back. So at the moment, something like Kew, some of our grasslands will actually get quite dry, they'll get quite brown. That's fine. The grass is pretty good at dealing with that. It'll actually come back. Though we get very used to sort of looking at these perfect green lawns, and we can't get used to that anymore. We haven't got enough water to actually deal with that. So having that mixed environment is pretty useful. Having multiple bits into the system, have different species, different structures as well, is great for increasing the diversity in your soils, but also great for other parts of the environment, for birds and bees, etc.
And if the thought of messy gardens makes you twitchy, don't panic. You can still help without turning your lawn into a jungle.
It doesn't have to be one or the other. There's this misunderstanding that maybe you can't have the pristine garden side by side with the more wild approach, but you can. There are ways to kind of dress things up, I suppose. And partly we'd like to show that in the carbon garden. We've got this long grass area where we just mow a strip around the edge, and it just neatens it up. It kind of gives it a boundary, it contains it and makes it a feature rather than just being a forgotten area. In the wildflower meadow, we've got this kind of really lovely woven hazel fence, which again just contains it and makes it a feature. And it's not always just leaving it and letting it do its thing. That is great as well, and that will produce a habitat that is suited to the conditions which you find yourself with. But you can do things sustainably, which will result in even better looking things.
Of course, with their encyclopedic horticultural know-how, we suspected the team at Kew are doing slightly more than embracing the mess. So how exactly are they adapting?
Yeah, so that's the big question. So we have to look at it as an ecosystem. So currently we're a moist temperate ecosystem, so we still do get some summer rainfall. We know like the summer and drought of 22, and again this year the summer drought this year, that's going to become more normal. So we have to understand that. So we will shift to more of what we would call a continental stroke steppe environment. So that's where you get very long and hot, dry summers. You get warm and wet winters, but late winter will be cold and your spring can be cold and dry. So they're the things we start to look at. So what we do is we can then start modeling this across the globe and look at those ecosystems and look at how the plants grow there. So a lot of my work now is we go plant collecting into these areas because those plants have genetically adapted to deal with these stresses. Whereas our native plants and the plants that we represent here from Kew, from Asia, they don't have that genetic ability to adapt to this dry area. So what we're now doing is now looking at how plants adapt. So to do that, they use things called functional traits. So they are little mechanisms that they use within their cells or in their leaves to adapt to deal with this drought and heat. So that's what we look at. So basically I use lots of models, and then I started to use trait data to make sure to influence those models. So we're getting really good now predictions from this work.
For instance, this autumn, we're going to be trying to establish in our wildflower meadow. This year it was an annual meadow, just basically because of the time that we had and when we were putting it in. We sowed cornfield annuals. This autumn is the time that we're going to strip it right back, and we're going to be trying to establish a perennial meadow. So we're going to be sowing a plant called Rhinanthus minor, a yellow rattle, which is a hemiparasitic plant, which basically parasitizes grass plants, reduces the vigor of those plants, which enables perennial wildflowers to establish themselves. And those are the plants that come back year on year without having to self-seed. And
so it kind of thins the grass, is that right?
It just reduces the vigor, so it doesn't grow quite as strongly. Right. It just gives a bit more space for those perennial wildflowers to kind of get their roots in and get established.
From studying ecosystems across the globe to testing plant traits and championing perennial wildflower meadows, it is a proper cocktail of practical steps. But here's the thing. Not every plant adapts equally well. Are some species tougher and more resilient than others?
Yeah. So if we look at things like Colateria paniculata, the golden rain tree, that grows in arid conditions. It grows in steppe environment in central China. So that plant has all the traits, so all the toolkit to deal with these long hot periods. and it's got those tools because it's naturally occurred in those areas. And if you come here to Kew and you see these plants in the landscape, they're performing really well. They've still got glossy green leaves, and they're still dealing with. And it's the same with things like Tilia tomentosa, the silver lime that grows in the steppe, and that's well adjusted. That's performing really well. So it's not all doom and gloom. And what a lot of the work that I do now is what we perceived as an English native tree. So let's use small leaf lime, for instance. That grows from Ireland all the way out to Azerbaijan. So taxonomically, that is the same species, but you have interpacific variation, so it changes genetically. So what we're doing now is selecting plants that grow in our future environment. So I've done lots of collections in south central Romania on the steppe. I've also done lots of plant collections in Georgia. Now, Georgia's really interesting, the country, not the state, because of where it sits. It's in Central Asia there, and you have the Greater and Lesser Caucasus, and you can hit every ecosystem there. So we've been collecting right into the south, so right in against the Azerbaijan border where it's really warm steppe, and we've collected lots of plants from there, and now we're growing them here at Kew because they have genetically adapted to our predicted future. Now, what I am doing as well as part of this work is we're growing these trees on from seedlings, obviously for the living landscape here at Kew, but also to do research to understand what have they adapted compared to our native tree. Because taxonomically they're the same, but they're very different, growing in different environments. But what we do know, which is really interesting, which people don't think about, people always think that tree mortality is driven by heat. It's not. It's humidity and water.
Kevin, Justin and Joe are having to deeply understand today's trees and then imagine them flung into the future. So is our best bet to start planting as many resilient, adaptable species as possible?
I think at the simplest level, when we're often thinking about planting more trees, but we must remember that most of our carbon, especially above ground, is sitting already in our forests. So our number one priority is actually protecting those or keeping those sustainable. So it really does annoy me sometimes when you see large tree planting schemes and then we're still deforesting at the other end. We made a big problem for ourselves at that point. And remember, those really big old trees, they're the things we need to go for. So whilst young trees are actually fast growing, they're not the big absorbers of CO2. Your big old trees are actually the absorbers. So we need to be thinking about, not now, we actually need to be thinking 200 years in the future. That's where we need to be thinking about what we're doing now. So getting those old trees into the landscape, getting the landscapes more sustainable, more resilient.
That's incredible, because so much of this conversation is always centered around 2050, and perhaps with good reason, because that's when we've set the planetary boundary around warming, etc. But 200 years into the future, that feels, I don't know, weirdly hopeful.
Well,
you can start something now and it's going to have that positive impact in the future if you do it in the right way.
Yeah, realistically, we're planting for our next generation, and truthfully, we're actually planting for 3 or 4 generations in the future. So whatever we plant now, our children's 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 will be actually looking after that or having that environment. So we do have to think quite carefully about what's going into that landscape and understand, hopefully, that we'll get it right. But realistically, nature offers us some fantastic solutions. It's to some degree, we wouldn't lose much if we did it anyhow. It would actually give us more gain in our environments. It's still not going to get us out of our CO2 trouble. We need actually more technologies beyond planting more trees or getting more resilient landscapes. But if we carry on destroying stuff, then we're actually just causing more problems. So by looking after both, hopefully we can sort of mitigate, we can get rid of some of the problems or reduce some of the problems by having more trees, having more shading, more cooling in the environment, as well as absorbing some of the more CO2 in the environment as well.
By this point, Imogen and I were kind of blown away. This whole conversation wasn't just about 2050. It was about really caring for the far future, beyond our lifetimes even. Naturally, we wanted to know, how did these guardians of tomorrow end up at Kew?
Not to give you a life story, but I'm a career changer. I worked in music before I worked in gardening, and I sort of had a epiphany moment where I really wanted to be working outside, doing physical work with my hands. So I retrained and I became a gardener. And I think the the key thing for me early on in my career, realizing that this was a very fulfilling career, was that, I mean, precisely as we've been talking about with the carbon garden, you can do things which feel sort of important and like you are feeding into a way forwards for human interaction with nature, I suppose. Well, ultimately, that's what gardening is about. It's about how we as people interact with nature in our own backyards. It's also, of course, Kew. Kew is, its mission is to demonstrate the importance of plant and fungi to the world, and really kind of gaining the insight. We have incredible collections here. Obviously, we have like an aesthetic garden that people can kind of come and look around and see a beautiful garden. But the sheer diversity of the collections we have, the different plants and the stories that each of those plants tell, it is quite incredible, really. So getting an insight into the plant world, or more of an insight into the plant world, and just how fascinating and special it is.
So for me, I started my career as a commercial tree surgeon. I wasn't an academic. Ended up at Kew, and I was a lead climber, and then progressed through. Now, for me, especially being head of trees, you have a massive responsibility on trying to create and manage a landscape for future generations. And I think it's the passion for that. And like, trees are amazing things. They adapt, and there's so much going on, and we all take them for granted, and we just walk by them. And for me, for the urban environment, we know we need green infrastructure in the urban environment to cool our urban hit cities. We're not doing that efficiently, and that's something I'm really passionate about, because if we can get trees growing in the urban environment, we can then cool that air, which then makes it better for everyone. And that's something that no one's looked at properly. I've given big talks to the environmental committee for City Hall talking about this, and it's something that's just been completely overlooked, because you will see these vast planting numbers, and there's always political will and funding for planting trees. But how do we know we're planting the right tree? How do we know that tree is going to provide that required surface that we do, which is air cooling and shade, for instance? So, and we have a high mortality rate. We lose a lot of these newly planted trees. So I think my passion for it comes from just trying to change that one thing and try to use a better approach to select the right tree for the right place. And we've always just gone on experience and gut instinct. There's never been an analytical way to look at it. And I suppose that's where the passion for it all started, really, was trying to think of a better way of making sure we're selecting the right tree for the next generation. That's sort of how I got so passionate about it, was trying to answer those questions.
Kevin is working with nurseries and cities across the UK to get them planning for the long term, choosing the right trees for the right places, not just for today, but for centuries ahead. Now, during our conversations with the team at Kew, we've learnt a lot, including some amazing new phrases like Colrateria paniculata and xylem cavitation. We've learned why fungi matter, why messy leaves are magical, and why resilient garden design is crucial. But if we had to boil it all down, what's the one big juicy message here?
If we think about what the Victorians did, especially for horticulture and ornamental horticulture, they did all those plant expeditions, and they were always collecting for wonder and beauty and desire. And that's why arboretums were created. And really, we're doing the same now, but this is for resilience. We can't keep selecting trees because they look pretty and they got a nice flower. We need them for the function we require them to do in the landscape. So if we're thinking in the urban environment, if you want air cooling, you need a tree that can deal with heat and drought and is actually growing, so it's producing transpiration and cooling the air. But if it can't, and it's going into a stress strategy to save itself, it's not providing that surface.
I think it's the variety of solutions that nature offers us. We've talked almost exclusively about carbon here as well, but nature offers us a lot of solutions that we can deal with in our environment at the moment. So as well as producing those sort of trees that we can absorb the CO2, but it gives us structure, it gives us form in the landscape, it gives us cooling in the landscape, has lots of cultural value. To describe and look at a tree. I mean, most people have a favourite tree in their street or a tree that they enjoy. I think they're also just as important. So even from our human health and well-being, these are just as important that provide us from nature, as well as giving us the CO2 absorption. One of our big aims was to not let it be just negative. So yes, there is quite a lot of stuff about how we do need to try and control our emissions, because that is what is contributing to climate change. But there is more kind of positivity about how incredible plants and fungi are in their role in how they contribute to the carbon cycle, but also how they can kind of be our allies in mitigating some of the worst impacts of a changing climate. So, for instance, the trees and the impact they can have on the temperatures underneath them, the bioswale in helping to manage floodwaters, the choice of plants in the dry garden not using resources so much. So it's these kind of positive messages that we really want people to take away, as well as just an understanding that carbon isn't just the big baddie. It's fundamental to all life on Earth. We need carbon. It's the building block of all life on Earth. It's just that our interactions with it have unbalanced a natural cycle. So that understanding, I think, is a really key takeaway.
Some wise and hopeful words. Thank you so much to Kevin, to Joe and to Justin for joining us on this episode and for sharing their incredible work. And of course, a really, really big thank you to the fabulous Chloe Wells at Kew, who made this entire episode possible.
We hope you enjoyed this episode of Green Queens.
If you did and you'd like to hear more, we'd be so very grateful if you could like,
subscribe and join the Green Group Chat for weekly episodes.